Hello everyone, welcome back to our math lesson. So today we'll be continuing our travel graph, which is speed time graph. Alright, so please get ready with your notes and your graph paper. So by the end of this lesson, you should be able to construct the speed time graph and then calculate the acceleration and deceleration based on the information you see on the graph. So these are the steps to success for this lesson. The first step is that you have to highlight the key information. Second, you have to draw a graph with two axes, which is speed and also time. The third one is that plot the points and connect them together. And lastly, you have to solve the problems that is related to the graph. So the second subtopic, which is speed time graph. So for speed time graph, the y-axis is always speed and the x-axis always time. Okay, so speed time graph. For speed time graph, the graph it describes the movement of an object. Okay, and then from the graph we can also detect or see the speed of the object traveling at the point. The third one, from the graph we can also calculate the acceleration of the object. So to calculate the acceleration of the object, we need to find the gradient of the graph or the gradient of the slope, which is y2 minus y1 divided by x2 minus x1. And lastly, from the graph we can also find the distance traveled, which is area under the graph. But this part we'll be learning this part next lesson. Okay, so first, how to interpret this speed time graph. So for example, you have this graph. Y-axis is the speed, x-axis is the time in second. So if you see a slope, okay, increasing slope, this line going up, it means that it has a uniform acceleration, constant acceleration with a positive gradient. Alright, so next, if you see a constant slope like this, meaning that it has a uniform or constant speed, but it has a zero acceleration. Next, if you see a slope that is going down, meaning that it has a uniform deceleration. Okay, so if it's a deceleration, the gradient of this slope will be negative. And also, the steeper the gradient is, the greater the acceleration or deceleration. So this is how we interpret a speed time graph. So we have to know, to find the acceleration, we have to find the gradient of the slope. Okay, and if the slope is straight line, just like this, flat section, meaning that it has a uniform or constant speed but zero acceleration. And always remember, if your gradient is negative, it means that it has a constant deceleration. So deceleration means it's the speed of the object is getting slower and slower. Okay, so let's see an example. A car accelerates from rest to speed of 10 meters per second in 4 seconds. It then decelerates to rest in 2 seconds. A. Draw the speed time graph for the car. B. Work out the acceleration and deceleration. So first, you have to draw the speed time graph. So in this case, we have speed time graph. We have speed as the y-axis and time as the x-axis. Next, it says that the car accelerates from rest. So from rest meaning that has zero speed. Zero speed to speed of 10 meters per second in 4 seconds. So 4 seconds till 10, it accelerates, the car accelerates. Then the car decelerates to rest in 2 seconds. So it decelerates at 2 seconds, which is time is 6 seconds. So this is the graph for the speed time graph for this example. B. From the graph, work out the acceleration and deceleration. Acceleration means when the slope is going up, and deceleration means when the slope is going down. Okay, so let's work out the acceleration first. This one. So to find the acceleration, meaning that you have to calculate the gradient. So in order for us to calculate the gradient, we need to pick two coordinates or 2 points. Okay, since we can say in this case I pick 2 points or 2 coordinate, which is 0, 0, which is this point, and also the highest one, which is 4, 10. Okay, so apply the gradient formula, and then I'll get the acceleration to be 2.5 meter per second square. Okay, so since my gradient is positive, meaning that the car accelerate, meaning that it is acceleration. Okay, so now let's calculate the deceleration. So deceleration is that when the slope is going down this side. So we pick 2 points. In this case I choose 4, 10 and also 6, 0. I apply the gradient, and then the answer I'll get is -5. So since the gradient is -5, meaning that the car decelerates, so we can just write down as deceleration is equal to 5 meter per second square. No need to insert the negative when you write down the final answer. Alright, so that is how you draw a speed time graph, and also how you calculate the acceleration and also deceleration from the graph. Alright, so next, your part is that you need to complete all example 1 until 3 from your notebook. So let's say example 1. A car accelerated at a constant rate from 10 meter per second to 8 meter per second in 20 seconds. And then the car remained at a speed of 10 seconds and then decelerate at a constant rate to rest in 16 seconds. Draw its speed time graph and then find its acceleration and deceleration. Okay, next. We have to highlight all the key information. Once you highlight all of them, now you can draw the speed time graph according to this scale. Alright, you can pause this video. Okay, so I believe you have done example 1 already. Now please proceed to example 2. The diagram is the speed time graph of a car which, due to a red traffic light, it reduced its speed from 6 meter per second to 1.5 meter per second in 2 seconds. It then traveled at 1.5 meter per second for 4 seconds before gradually coming to stop. Okay, find A, the retardation meaning a deceleration also in the first 2 seconds. B, the time t second at which the car came to a stop if the retardation or deceleration after 6 seconds was 0.75 meter per second square. Okay, next you have to highlight those key information before you calculate the retardation. Okay, the first one, the retardation or deceleration in the first 2 seconds. So as usual, you just need to find the gradient of the slope. The second one, the time. So in this case, the time is not given, but the retardation or deceleration is given as this value. So you have to work it out using the formula of gradient. Okay, so pause this video again. Alright, very good. So I believe you have done example 2 already. Now please proceed to example 3. So the last example. The diagram is the speed time graph of a car which accelerated uniformly from rest and reached a speed of 25 meters per second after 5 seconds. The first one, calculate the acceleration of the car, and B, you have to find or calculate the value of V. Okay, so in this case, the acceleration of the car will be, I know you can calculate already. To find the value of B, you have to make use of the acceleration of the car here. Okay, the value of the acceleration. Alright, and also apply the formula of the gradient. Okay, so try to complete this example too. Alright, if you have any question, you can ask me and I will guide you to the correct answer. Right, so that's it for our lesson today, class. Thank you very much and see you next lesson.